Hello viewers, in today's session we are going to discuss one very important application of mean value theorem to the theory of equations, right? So here we have a problem from theory of equations and we'll try to solve this problem with the help of the mean value theorem, right? So here we are going to use the concept of Rolle's theorem to solve this problem. So let us first read out this problem and then we'll see how we can solve this problem with the help of the famous Rolle's theorem. So here we are given a cubic equation and we have to show that this equation 3l x cube plus 2m x square plus n is equal to 0 has at least one root in the interval minus 1 comma 1 if this condition holds, that is 2m plus 3n is equal to 0. And remember here the quantities L, M and N are the real numbers. So in this problem, we have to show that this cubic equation has at least one root in this interval if this condition prevails, right? So here we have a cubic equation and we know that a cubic equation has three roots, and out of these three roots this equation has at least one root lying in this interval minus 1 comma 1 provided the sum of these two quantities, that is twice of m plus thrice of m, is equal to 0, right? So we'll tackle this problem with the help of Rolle's theorem. So let us quickly see the statement of Rolle's theorem. So here if we have a function, say y is equal to f of x, which is defined in some domain D, and if we take an interval say a comma b, and if this function y is equal to f of x, it is continuous in the interval, that is the closed interval a comma b, and if this function f of x is differentiable in the open interval a comma b, and the third condition is that the value of the function at these two extreme points, that is f of a is equal to f of b, then the Rolle's theorem says that if a function y is equal to f of x, which is defined in some interval a comma b, and if it satisfies these three conditions, then there must exist some point that is x is equal to c lying between a and b, such that c is greater than a but less than b, and we have the derivative of this function at this point c is 0, that is f prime of c is equal to 0, or we can also write f prime of x is equal to 0 at x is equal to c, right? So we have already discussed Rolle's theorem and the related problems in our earlier videos, but here we'll apply Rolle's theorem to solve this problem. So here we are given this equation, that is 3lx cube plus 2mx square plus n is equal to 0, right? So this expression is given to be equal to 0, right? Now if we compare this equation with this one, that is f prime of x is equal to 0, then we can easily see that f prime of x is given by 3lx cube plus 2mx square plus n, right? So we are given this equation. This is a cubic equation, and from Rolle's theorem we know that the derivative of this function is 0 at least at some point x is equal to c lying between a and b, right? So if we compare f prime of x is equal to 0 and this equation, then we can conclude that the derivative that is f prime of x is given by 3lx cube plus 2mx square plus n. Now f prime of x can be written as df over dx, and we can now find out the function by integrating both sides with respect to x, right? So integrating both sides with respect to x will have integral 3lx cube 2mx square plus n, and here we have dx. So this side is simply f of x, and here we have 3l x raised to 4 over 4, because the integral of x cube is x raised to 4 over 4. Here we have 2m x square has the integral x cube over 3, and here we have simply n. So the integral dx is x, so we have nx, and here we have the constant of integration as say p, right? So p is the constant of integration. So by integrating this function, we have obtained the form of the function f of x. So now we have obtained the form of the function f of x, and this function f of x is a polynomial of degree 4, right? So the degree of the function f of x is 4, and it is a polynomial function. And let us see the conditions of Rolle's theorem for this function f of x in the interval minus 1 comma 1. So now we have this interval that is from minus 1 to 1. So the value of a is equal to minus 1 and b is equal to 1, right? And our function is f of x, which is a fourth degree polynomial. So let us see the conditions of Rolle's theorem. Now see, all the polynomial functions are continuous, right? So this function is continuous function in the interval minus 1 comma 1, right? So this is the closed interval, and moreover, all the polynomial functions are differentiable, and this function is also differentiable in the interval that is open interval minus 1 comma 1, right? And moreover, the third condition, that is f of a should be equal to f of b, right? So we should have f of minus 1 should be equal to f of 1. So let us find out the value of f of minus 1. So we have 3l over 4 minus 1 raised to 4, and then we have 2m minus 1 raised to 3 over 3, then we have n times minus 1 plus p, and f of 1 is 3l over 4. Here we have 1 raised to 4, and then we have 2m over 3. Here we have 1 cube, then we have n times 1 plus p, right? So f of minus 1 can be obtained by taking x is equal to minus 1 in this polynomial, and f of 1 can be obtained by taking x is equal to 1 in this polynomial. So now let us rearrange the terms on both the sides. So we have 3l over 4 minus 1 raised to 4 is plus 1, and here minus 1 raised to 3 is minus 1. So we have minus 2m over 3, and here we have minus n, here we have p. Here we have 3l over 4, here we have 2m over 3, here we have n plus p, right? So let us cancel the common terms here. So these two terms get cancelled, and here p and p also get cancelled, and we are left with only these two terms and these two terms. So now taking these two terms to the right hand side, so we have 2m over 3 plus 2m over 3, and here we have plus n is equal to 0. So here we have 4m over 3, adding these two terms, and n plus n is 2n, that is equal to 0. So multiplying both sides by 3, we have 4m plus 6n is equal to 0, and dividing both sides by 2, we have 2m plus 3n is equal to 0, right? So this is our desired and required condition, right? So this equation, which is a cubic equation, has at least one root in this interval minus 1 comma 1 if this condition holds, right? And we have obtained the condition as 2m plus 3n is equal to 0. And here always remember that this c, it lies between minus 1 and 1, right? So c, it lies between minus 1 and 1, because here c lies between a and b. So viewers, in these type of problems, what we do, we first obtain the function f of x from the given equation, right? So this part of the equation may be treated as the derivative of f of x, right? So f prime of x may be taken as 3l x cube plus 2m x square plus n, and then we can integrate the equation, and we can get the function, right, f of x, and then we can satisfy the conditions of Rolle's theorem to this function f of x, and we can obtain the condition which is required.